Okay, this is the P3 paper from January 2024. It's question number 8, and as you can see as I move up and down this, it's a functions and graphs question, but in particular it's modulus function, the modulus function that we're going to be looking at. So let's have a look at it. It says the graph shown in figure 2 has an equation y equals a minus 2x minus b. That's the equation. And it says a and b are positive constants, but a is bigger than b. Okay, fine. It says, right, fine, can we give our answers in terms of a and b, coordinates of the maximum point of the graph? We'll just do it step by step. So first of all, we want the coordinates of that maximum point there. So let's have a look at our function, because we can do this one. So a, part 1, we've got that y is equal to a minus the modulus of 2x minus b. So just logic decides that if this is a modulus function, then this is either positive or 0. So if I'm doing a minus something, for y max, I want that to be as small as possible. So y equals a minus 0 will be y max, so y would equal to a. So that's the maximum value y can take. It wants the maximum point of the graph though, so we need to know when does that occur. So that occurs when 2x minus b works out to be equal to 0. And if 2x minus b is equal to 0, rearrange that, we get x equals b over 2. So the maximum point as a coordinate then is going to be b over 2, comma a. So that's a part 1 done. Maybe just put it on the graph. I don't think we necessarily need it, but we can just put, then this is b over 2, comma a is that point there. Second one then says, can we find the coordinates of the point of intersection with the y-axis? So that's this point here now, and it's going to intersect with the y-axis when x equals 0, isn't it? So part 2, graph intersects with y-axis when x equals 0. When x is equal to 0. So y, remember, was equal to a minus 2x minus b modulus there. So when x is equal to 0, we're going to get y equals a minus 0 minus b there. So in other words, y is going to be equal to a minus b. So the point that we would want, point of intersection, is given by 0 a minus b. So this point up here then is 0 a minus b, and that's the second part done. And then the third part says, where does it intersect with the x-axis? So this time we're going to have the other way around, aren't we? We're going to have y equals 0. So I'm actually going to just copy and paste this so it'll be a bit quicker. Copy that, put that in there, and then change that to it intersects with the x-axis when y is equal to 0. So if y is equal to 0, I get 0 equals a minus 2x minus b, modulus of that. So rearranging that, I'll get a equals the modulus of 2x minus b. And so I get my two different possibilities. I can get where this was a positive, and I can get where this inside was a negative. So if it's positive, I'm going to get a equals 2x minus b, and then just rearrange that. I want to get x equals, so x plus a equals, no it doesn't, sorry, a plus b equals 2x, so x is equal to a plus b over 2, and we could have had a is equal to minus 2x minus b, which would give me a is equal to b minus 2x there, and if I rearrange that, I'm just going to do that quickly, rearrange that there, I'll get x equals b minus a all over 2. So the 2 points then are a plus b over 2, 0, and b minus a over 2, 0. Okay, so that's all of part B, all of part A done, parts 1, 2 and 3, and it then says, on page 24 there's a copy of figure 2 called diagram 1, so we'll have a look at that in a second. On diagram 1, sketch the graph with the equation y equals the modulus of x minus 1. So let's go and have a look at that. Where's the graph? It's here. Okay, we're just going to build this up. So this is where the video comes quite useful here, in that when I'm doing this, I wouldn't leave all this on my actual answer. The answer will be the answer that's left at the end of it. So if I want to do y, let's just put it up here. I want y equals the modulus of x minus 1. So really slowly, we'd start off with y equals x first of all. Then we can turn that into y equals the modulus of x if we just get rid of this part down here. So that's now y equals the modulus of x, and if we want to do y equals the modulus of x minus 1, then this whole graph here is going to have to go down by 1 unit there. No, so if it goes down by 1 unit, what happens here is that this will become minus 1. And because this is y equals x, we can straight away say what those two values are. This is 1 and this is minus 1 without doing too much extra work. So I think I would just leave it like that rather than saying that it happens when y equals 0 and then rearranging it and getting the values. Which you can do. You can do if you want to, but we're not going to get any extra marks for saying if I want to work out this point here and this point here, it's going to be when y is 0. If y is 0, how does that work out? X would have to be equal to 1 or minus 1 in there. But we're not getting any extra marks for that, so I'll just leave that as it is. That's my sketch with enough information. Let's just go back and see what they wanted. On the diagram, sketch the graph with the equation, just 2 marks for it. Okay, so they haven't said anything else from that. And then they say, right, this is quite complicated, this last part. So they say, right, okay, once we've got that, these two graphs are going to intersect at x equals minus 3 and x equals 5. Can we then find the value of A and the value of B, okay, if they intersect at that point? So let's just have a quick look at this first of all. We go back here. Let's get rid of that part up there. Didn't need that. So what they're saying then is that these two graphs are going to intersect, and I can see they're going to intersect at what I'm going to call point A here. Let's just get rid of the highlighter bit, sorry. Give me 1 second. Let's just make that easy to get rid of that and get rid of that. Yeah, I think they're going to intersect then at this point A here, and they're going to intersect at this point B there. So for the point A, I can see that x is equal to minus 3, and for the point B, I can see that x is equal to 5. What I really want is to have this diagram, so I'll do a little bit of writing here and then we'll translate it up in a minute. So if I want, for point A, so I'm going to say this now, but I'll move it up later on in a second. For point A, we know that x is equal to minus 3, because it's on this side of the graph here, so I can see that x is equal to minus 3 there. But what I can actually do is I can think about what the two graphs look like, and I can see this one has a negative gradient, whereas this one has a positive gradient. So if that's true, when I'm trying to work out what I'm going to equate to each other, for my modulus x minus 1, for that one, rather than taking the positive one, I'm going to take the negative gradient of that. So I'm going to say minus x minus 1 is going to equal to, and then when I've got my a minus modulus of 2x minus b1 here, I can see that's when that's going to be a positive gradient. So if it's a positive gradient, this thing has got to work out as being a plus once I've tidied it all up. So it's going to be plus that one there. If I then follow that through, I can work out what it works out to be. So remember, x is -3 here. So I get 3 minus 1 equals to a plus -6 minus b here, which is going to give me, when I tidy it all up, I'll let you do it, a minus b equals 8. So all of that work there is for this point here. I'll move all that up a second once we've just gone through for point B then. For point B, so I'm now looking over here, this side, now I've got a positive gradient for my modulus x minus 1, but a negative gradient for the other one. So when I'm trying to work out what's going to be equal to what, we know it's x equals 5 because they told us that in the question, x equals 5. What I'm going to have is the modulus of x minus 1, that one there, I'm going to want that to be a positive gradient. So when I get rid of the modular signs, I keep the positive gradient there. And on the other side, following exactly the same argument through, I've got a minus the modulus of 2x minus b here, but I want that to be a negative gradient. So if that's a negative gradient, I need to replace that with a bracket, but I'm going to have that situation. And again, knowing that a is equal to 5. So if a is equal to 5, I now get 5 minus 1 is equal to a minus 10 minus b here. And you take a little bit of time, but that all should tidy up to a plus b equals 14. So let me just tidy that up in terms of what I've got written down as my final solution here, just because obviously I've got a little bit of space to do that. I'll probably do it here. So I would put that there, and then put that afterwards as there. So the whole point about doing that then, remember we're trying to work out what A and B are, but we've now got these two simultaneous equations. So because we've got these two simultaneous equations, we can just solve them. So what I'm going to do is, if I label this 1 and label this 2, I'm just going to do 1 plus 2 to see what cancels out. So let's have a go at doing that. I'll get, in fact, the video's taken long enough, I'll let you do that. It works out to be 2a equals 22, which gives us a equals 11. And if a is equal to 11, again, just looking in there, b is equal to 3. So I'm sure you can do that, those last couple of steps to that. Yes, that's a really interesting one of these types of questions, these modulus function questions. They can be quite difficult, and I don't think that's a particularly easy one either. You might need to watch that video a couple of times, but hopefully eventually it will make sense to you.